Press the bell icon on the YouTube app and never miss another update.
See the next method to locate the center of mass. Anyhow, we covered method of integration. By using method of integration, we have derived already center of mass of semicircular wire and half disk. Here, by using one more theorem also, we can derive center of mass of semicircular disk and semicircular wire and triangular plate also. Okay, let us see how to derive that formulas by using Pappus theorem. So this is very simple. According to first statement, means first theorem, so it states that for suppose if any semicircular disk is there, this is the semicircular disk. If it is rotated like this, if the semicircular disk is rotated, then that rotation will cover a volume of the sphere. Okay, so this rotation will cover some volume. A volume is generated. So volume is generated by the revolution of a closed plane lamina. This is the closed plane lamina. Okay, volume is generated by the revolution of a closed plane area, which is equals to area of that body into distance of center of mass moved. Distance of center of mass moved means anyhow it is circle. So let us suppose distance of center of mass is 2 pi r, 2 pi by cm. Here volume is 4 by 3 pi r cube. Area half circle pi r square by 2, 2 pi by cm. So 2, 1 pi, 1 pi, 1 r square, 4 r and 3. See, check the conditions. 4 r by 3 pi, which is equals to what? Y coordinate of center of mass for a semicircular disk. So this is for semicircular disk, half disk. In the same manner, if you rotate a wire, means if any semicircular wire is rotated, means the revolution of a closed, see this is not a closed, sorry. If any semicircular wire is rotated, then it will cover some area, means area will be generated. Earlier it sweeps out all the matter, so volume is generated. Here only area will be generated. This area is equals to length into distance of center of mass moved. Area of the sphere, hollow sphere. This is solid sphere, hollow. So 4 pi r square, which is equals to length is pi r. Length is 2 pi r, nothing but pi r, 2 pi by cm. So just you check it, 1 pi, 1 r, 2, 1 r is there. So verify the calculation, 2 r by pi. 2 r by pi. In the same manner, if you take a triangular plate, okay, see this is the triangular plate whose base area is B something, this is A, and if it is rotated like this, then here the volume is generated. This volume is generated is equal to area into length 2 pi r. So you will get again y coordinate of center of mass is like a h by 3, like a, so some value you will get here. Okay, just volume is equal to convert volume into area of the triangular plate and distance of center of mass moved. Then you will get the answers. Okay. Anyhow, you learned the integration method. Better you practice the integration methods. And next, let us see some blocks concept in center of mass. See some blocks concept. They given n identical blocks. They are placed one over the other, so that blocks does not double. For suppose they given 2 blocks. If they given for 2 block system, okay, blocks are having same mass, same length. If I want to place one block over the other block, definitely see here one block whose center of mass is something C1 here. Okay, if I place another block at this, means the edge of other block at the center of this one, otherwise center of mass of this block must be at the edge of the first block. Okay, so count from top, okay, or bottom, that's not an issue. So here L is length and here L by 2. So the block extends by L by 2. If it is more than L by 2, this block topples. Okay, this block topples. So the final is the maximum extension so that the second block does not fall from the first block is L by 2. Okay, for suppose, see, to place this block, you keep the center of mass of this block, must be at the edge of the lower block. Center of mass of this system means which one does not fall from the block, that center of mass must be at the edge of this block. Then this one does not topple. For suppose, these two blocks are placed on one more block. Okay, so if they given 3 blocks, for 2 blocks, C1, C2 are the center of masses. Okay, but for these, there will be a center of mass. Okay, for these 2 blocks, there will be a center of mass. Let us suppose C is the center of mass. Take this as a origin. And here let us consider something x2. If this is x1 and this is x2. Okay, so this is L by 2, this is L by 2, no doubt this is L by 4. If you want to use the formula, you can use formula x2 is equals to m1 x1 plus m2 x2, like that only possible. So this x2, if I want to find m into 0 and this m into L by 2. Okay, so m into 0 plus m into L by 2 by 2 blocks, 2m, because I am finding center of mass for only 2 blocks. So you will get L by 4. So how much is x2? x2 is equals to L by 4. So you keep this center at the edge of the third block. Then these 2 blocks does not fall. Means for 3 block system, see the 3 block system looks like this. See, this is the, from the top I am counting. This is L by 2 and here see center of this one at the edge of this one, so that this one does not fall, and here this is the center of this system and here you keep one more block. This is x2, nothing but how much distance? L by 4, and here center of mass of these 3 systems will be here. Okay, middle. This is L by 6, next L by 8, L by 10. So the maximum extension of the nth block, such that the maximum extension of nth block such that the blocks does not fall one over the other, blocks does not topple, topple is L by 2n. For 2 blocks, L by 2. For one block, if you want to keep one block does not fall on the other block, just you keep it is at a distance of L by 2. For 3 blocks, see, for just substitute n1. For 1 block L by 2, for 1 block L by 2, 2 blocks L by 4, 3 blocks, just substitute n value L by 8. For suppose they given 3 blocks, 3 identical blocks, they place one over the other, such that each one extends the same length, so that the blocks does not fall. So if you arrange like this, see, if they given 3 blocks, let us suppose x. If they given 4, x. See, for 4 blocks, if you keep this x is something, if for 4 blocks, you keep this one by L by 4. And there is a shortcut formula L by n, where x is the equal extension from the edge of each block. Same extension from the edge of each block. So here if they given 4 blocks, if you keep L by 4, then these blocks does not topple. And if this system is placed on table, if this system is placed on something table, if they given, Okay, edge of the table. Then use maximum extension of this is formula n plus 1. For 3 blocks, substitute n value 3 plus 1, 4, like that, L by 4 distance. For 5 blocks, L by 5 plus 1, L by 6, like that. For suppose they given one simple question like this. They given 3 blocks, placed one over the other. So let us suppose they given 4 blocks. Let us take 4 blocks. See, they given 4 blocks, they are placed one over the other such that the blocks does not topple from one with respect to the other. Okay. So like that they placed. See, this is one block. Okay. And here another block is like this. This is how much? L by 2. And this center of mass. So you keep one more block here at the below only. So this is how much? L by 4. And here L by 6. Here if this is x, then how much is x value? If they ask the x from here, okay, if they ask from O and this is something P, if they ask from x from P, just x is equals to L by 2, L by 4, L by 6. All these conditions are given, unequally spaced. If it is equally spaced, how many number of blocks? 1, 2, 3, 4. L by 4, L by 4, L by 4, like that. Unequally spaced. L by 2, L by 4, L by 6. Okay, so x is equals to, if you take LCM, 12. So 6L, 3L, 2L, you will get 11L by 12. Okay, so if they ask you to find from O plus L you do. Okay, so if they ask from O, just you add plus L, you will get the answers. If they ask from center, L by 2 plus this value. Okay, now see the next one more good question. They given 7 homogeneous blocks. So this problem from next one. So they given 7 homogeneous blocks placed one over the other such that they does not topple, and each one extended by something L by 10 is given. See, they given the diagram like this. So 7 homogeneous blocks. Let us suppose, see, let me draw the diagram first. This is the first block. Okay, next block extends by something L by 10. L by 10. This is block number 1, block number 2. Block number 3. Block number 4. Okay. And they give it this one. This is 5. This is 6 block. And this one seven blocks. Each extends by L by 10 gap. L by 10, L by 10, L by 10. They given L by 10, L by 10, L by 10. This is also L by 10, L by 10, L by 10. Now they are asking to find center of mass of this system from O. See, they given 7 homogeneous blocks. They placed one over the other such that each extends by, with respect to the previous one, each extends by L by 10. Now, target is to find out x coordinate of center of mass from O. Okay, anyhow here the origin is O. Center of mass of this one, L by 2. For the next one, first one is L by 2. Next one extend by L by 10. So second particle, second rod, center of mass is located at L by 2 plus extra L by 10. Third one, L by 2, extra L by 10, L by 10. This one, L by 2, L by 10, L by 10, L by 10, 3 L by 10s. This one, L by 2, L by 2 is common for everyone. And see, L by 2, how many? L by 10, L by 10, extra. This is L by 2 plus L by 10. Last one, only L by 2. Now let me write x coordinate of center of mass is m into first one L by 2, first one L by 2, second one extended by L by 10 part. So m into, let me write L by 2 plus L by 10. Third one, 1, 2. So m L by 2 plus L by 10, L by 10. So let me write L by 10, no problem. Next, third completed, fourth. Let me write here. Fourth, m into L by 2, L by 10, L by 10, L by 10. Let me write directly 3 L by 10. Fourth completed. This one, m into L by 2, L by 2, and this one is at L by 10, L by 10. So let me write directly 2 L by 10. M into this one, L by 2 and only L by 10. Now last one, let me write here M into L by 2. Total divided by 7m. Total value divided by 7m. Mass anyhow gets cancelled. Okay. Just you count L by 2 first. 1, 2, 3, 4, 5, 6, 7. So 7 by 2. Count L by 10s. 1, 2, 3, 6, 8, 9. So this is 70 plus 18, 88 L, and 2 into 10, 20. So you will get 4 2s are, 4 5s are 22 L by 35. So here you identified L by 2, next one extended by L by 10, L by 2 plus L by 10, next L by 10, L by 2 plus L by 10 plus L by 10. So simplify this one, verify the calculation, you will get some number. Okay, now I got 22 L by 35. Check it. Check the calculations. See some more questions. Anyhow, we already covered some method of decompositions. Okay, some circular disc, for a circular disc, one more circular disc is cut. Okay, let us suppose, let us try some more, 2-3 more questions, and let me stop the center of mass. So let us try few more questions. See the given circular disc, whose radius is r again, whose radius is r. From this, a square plate is cut, whose side is r by 2. This is cut. Okay, from solid sphere, a solid cube is cut, like that also they may give. In that case, you can use volume. Here, area is sufficient. So, this one, anyhow, you have remembered the formula, mass removed. Mass removed is, anyhow, mass removed formula, you know, it is proportional to area of the square plate. So mass removed r square by 4, and center of mass of this one. See, this is already how much this one? This is r by 2, and this part is how much? R by 4. Total mass pi r square by 4. Just r square you can strike off it. R by 16. 4 pi minus 1 r by 4 into 4 pi minus 1. Okay, verify these things. Now let us see some more easy things. See, they are asking to find center of mass of the system from O that is given in the diagram. See, they given the diagram like this. They given this. This side is mentioned 2R, this is R. Okay, they are asking to find center of mass of this sheet. See, this is empty, already cut. This part already removed. Okay, this is already cut, already removed. They are asking center of mass of the system, remaining part from O. They are asking center of mass of remaining part from this O. And see, this part is like a some semicircle. Okay, we'll decide this ring, we'll decide later. And this is like a plate whose sides are given. So let me draw this diagram into two parts. So from a full rectangular plate, see, this is the rectangular plate whose side is given R. See, this is the rectangular plate. From this, if I cut this part, I will get the given portion. So subtract from this one. See, the given diagram is equivalent to these two diagrams. If you cut this part from this, you will get the given diagram. Now to find center of mass of this type of questions, use again the same formula. Like you know m1 x1 plus m2 x2 by m1 plus m2. But here some part is removed. You can use m1 x1 minus m2 x2 by m1 minus m2 because mass is removed. Some cutting part is there. And anyhow mass proportional to area. So as mass proportional to area, then you can use center of mass, maybe xcm or ycm. So let me take xcm in this direction. Okay, let us take xcm. m1 x1 minus m2 x2 by m1 minus m2. m1, anyhow mass proportional to area, better you can write a1 x1 minus a2 x2 by a1 minus a2 because mass proportional to anyhow area. So a1, area of this one, side into side, r into 2r, side into side, 2r square. x1, center of mass of this, x1. This is how much? If this is r, this is r by 2. Minus a2, area of this semicircle. Semicircle means it is pi r square by 2 because radius is r. Radius is r. Radius is r. And x2 is the center of mass. Center of mass. So center of mass is located for a disc. What is the formula? 4r by 3 pi. So for a disc, this is 4r by 3 pi. x2 is the center of mass of that part. Center of mass of the disc, semicircular disc is 4r by 3 pi. a1 minus a2. What is a1? 2r square. a2 pi r square by 2. Just do the simplification. Here this is 2 and r square everywhere cancelled. So just you verify some simplifications here. Here r square already cancelled. R, if you take out 1 minus pi gets cancelled. 1 minus 2 by 3, 4 minus pi by 2. So this is r3 minus 2, 1 by 3. Okay, so 4 minus pi by 2, 2r by 3 into 4 minus pi. Verify the calculations. So answer is 2r by 3 into 4 minus pi. Check the calculations. Here x2 is the center of mass of this part. Okay, now let us see some more easy questions. Say I am using m1 x1 minus m2 x2 by m1 minus m2. m1 nothing but mass proportional to area. Okay. Say they given this one. Square plate is given, whose side is mentioned to L, and this part is cut. Center of mass of this remaining system. Okay, center of mass of this system. Again, this is equivalent to one full square plate whose side is 2L, center of mass is here, okay, and minus, just I want to subtract this part, okay, and this is the center of mass. This side is how much? L. See, this is L, total is, see, this is L, okay. Now here, y coordinate of center of mass, of course, due to symmetry same, x and y. Here y coordinate of center of mass, we can write it as ycm, or we can write xcm. In this direction also no problem. So xcm is equals to a1 x1, a1 nothing but what? 4l square, a1 4l square, x1 how much? 2l by 2, l minus a2 x2, l square, x2 l by 2 by 4l square, l square. So L square, here 3 and here 4L. So 4L, L cancel. So 4 minus 1 by 2 by 3. So you will get 7L by 6. 8 minus 1, 7, 7L by 6. Check it, check the calculations. Let us try one more. Some cutting parts. See the given disc, this part. This is R. Second one is 2R. Center of mass of this part they are asking. Anyhow, mass proportion is to square of the radius. So you will get a mass also. Okay, as mass proportions to square of the radius, you can identify the mass. So to solve this one, just I am going to replace this diagram with two discs. One is a bigger disc, whose radius is 2r, minus smaller disc, whose radius is r. If m1 is the mass, m2 is the mass proportional to square of this. So square of this means what? 2 square, 4. So if m1 is equal to 4m, and what is m2? It must be m. Okay, m1 is 4m, m2 is m. Otherwise you substitute pi r square, you will get the same answers. So here center of mass of this one is at y1 is equals to 4r by 3 pi is the formula. Okay. So disc, what is the disc formula? 4r by 3 pi. 4r by 3 pi. What is the radius of this one? 2r. And here 4r by 3 pi. Now y coordinate of center of mass m1 a1 minus m1 x1 minus m1, you can write m1 y1, a1 y1, everything you will get the same answer. a1 y1 also correct, m1 y1, m2 y2, m1 minus m2. What is m1? 4m. y1 8r by 3 pi 2, okay, minus m 4r by 3 pi, and this one 4m minus m 3m. Anyhow, mass gets cancelled. Otherwise, you may get pi r square terms, pi and r square terms gets cancelled out. So you will get the answers. Okay. So if you extend, if you take 4r by 3 pi common, so 4r by 3 pi if I take common, this is 2. So 8 minus 1 by 3, 7. Okay. So 28 r by 9 pi. Okay, verify these calculations. So they may give anything like this. So they may cut in this direction. Okay, if one is 2m, other one is m, and this is like a triangular plate. I do know h by 3. If height is given, we can write h by 3. Okay, so this type of problem they may give. So this is also like decomposition, cutting parts. Okay, now see one more last question now. If they given some with string arrangement, for suppose they given a block whose mass is m connected to the spring, whose spring constant is k. This is 2m, which is moves with a speed v naught on surface, on smooth surface item. Okay. Here, what is the center of mass of the system? Velocity of center of mass. They are asking what is dcm and how much the elongation developed in the spring. What is the elongation? Okay, what is the velocity of center of mass and what is the elongation in the spring? To find velocity of center of mass, m1 v1 plus m2 v2 by m1 plus m2. m1 v1. So m into, this is nothing velocity is given to this. m2, 2m into v naught by 3m. So m gets cancelled, 2 by 3 v naught. So 2 by 3 v naught is what? Velocity of center of mass. Okay. And here, if they ask you to find elongation, you can use, already you know, elongation means C. Carry energy here converted into elastic energy, half k x square. Then this m you replace with the reduced mass concept. Reduced mass already covered, m1 m2 by m1 plus m2. Okay, so use this one as reduced mass. Reduced mass means what? m into 2m by 3m, and this is v naught square k x square. M gets cancelled, so you will get x is equals to 2m by 3k into v naught. Okay, so plenty of models are there. So let's see, in my class starting I covered some basic problems, okay, based on m1 x1 plus m2 x2 for n particles. Later we entered into some locate the method to center of mass, means location of the center of mass, and I covered method of symmetry, method of decompositions, and method of integrations. Okay, and finally just we covered the blocks concept. Okay, so try to follow all these concepts and try to solve the problems from different types of books. Definitely that what I cover here, it will helps a lot. Okay, still so many models are there, so here I cover maximum level of questions. Okay, and some conservation of momentum. I think for a boat man problem, you can apply the same boat man concept for wedge problem. There is a wedge whose mass is m, something 4 kg wedge is there, which is placed on smooth surface. These wedge problems will come in laws of motion, in constraint equations. If any 1 kg mass which is moved down, then this wedge will move back by something x. Okay, if it is x, then you can apply the same concept like a boat and man concept. So wedge is moves by x. Okay, in a horizontal direction. If this wedge side is something 4 meter, if wedge side is something 4 meter, so 4, this 4 into x, and this is covered how much? 1 kg 1 kg covered into 4 minus x. If you extend, you will get some answers. Okay, so in the same way, momentum concepts also there. We will cover momentum concepts in conservation of momentum. With a trolley, a 1% jump, 2% jumps, 1% jump right side, 1% jump left side, boy and kid like that. So those things I am going to cover in conservation of momentum. Okay, so thank you.